Hi to all. Okay, in this video we're going to cover our module 5 still, and in this video I'm going to cover 5.3, but 5.3 is a big subtopic. I guess as I mentioned, I'm not going to create a long durations of video, so that's why I'm going to cut 5.3 into 5.3 A and 5.3 B. I will see until where I'm going to stop, and I'm going to continue later on because it's depend on durations, how long I takes to explain. So without further delay and make this video even longer, so let's we start on our module 5.3. We're going to look into the overview in 5.3 and the indirect cycle, lastly the data flow, but depend on how long, okay, the durations while I explain. So the overview, the processing required for single instruction is called an instruction cycle. What is single instruction? Normally you see like MOV move EX 10, let's say. This is one instruction, and you can see in your Visual Studio there is a step override. When you press F11, if I'm not mistaken, so you can see it's step over. So this one step means that it is a single instruction. This is one instruction, and maybe you have another add EX 10 again. Let's say I just give you an example. So this is another single instructions. So this is the meaning of single instructions. So over here you have two instructions, and it called as instruction cycle for the process to finish this one single instruction. If you just using your Visual Studio, you press F11, you press F11 another one time, you will get the output automatically. It's very fast. It is a microsecond. That's why you cannot see basically what is happening inside your computer. So this is your computer, and let's say this is your Visual Studio. Then you press your F11 here on the keyboard. Then you can see your instruction pointer will jump from one line to another, and when you step over to this single line, then you're going to get the output from the previous one, which is already executed. And when you press another step over, you will get directly in a blink, isn't it? In a blink, in a second, you will get the output. But what is happening inside whenever you are doing or running this single instruction? So the time for processing your single instructions is instruction cycle. Okay, so that is on overview. And instruction processing consists of 3 stages. What that's 3 stages, which is first fetch cycle, execute cycle, and lastly interrupt cycle. I guess these also already occupy longer, especially in the example. Maybe I'm going to stop, but it's sometimes it's combined. That is in that example. We take a look after this. Okay, So in the overview, the processing required for single instruction called an instruction cycle. So there are 3 stages: fetch cycle, execute cycle, and interrupt cycle. Fetch the instruction, decode it, fetch operand if required, which is indirect. If required, it means that this is indirect, which is fetch operand. Let's say you already put the value in, so you just put it into it. So if required, indirectly, you're going to fetch your operands. And next is your execute cycle, perform the operation. So if let's say you have MOVEX 10, let's say, so you're going to fetch the instruction first and then decode it. You're going to decode this instruction to your machine language or any kind of decoded versions, as long as your computer understand it. Then if necessary, it's depend on what operands that you are using. If indirect, then you need to require to use the indirect operation. After that, you're going to execute the cycle. How you're going to execute is you perform the operation. This is the operation, which is you're going to move this value inside your register. And after that, after you move, you're going to store the result if it requires you to store it, isn't it? So you're going to store it into your AX. If you have the DUM register, isn't it? So if required, then you're going to store it into your register with the value of, let's say, 10 hexa. And lastly, the interrupt cycle. If recognize pending interrupts, later on you will see how the flow is look like, from first cycle and then execute cycle, interrupt cycle, and then it will loop again, depending on how many line, how many instructions you have in one source code. Okay, so here is the duration. You can see from your first cycle to your interrupt cycle, you have first cycle and then execute cycle and interrupt cycle. So you're going to start, let's say you press the bar in your Visual Studio. Then what is going to happen? Or maybe you press the F11 step over, or F10 what, I forgot. So you're going to fetch next instruction. Then after that, you're going to execute the instruction. Same goes what is explanation here. I already explained basically all of this. And then you're going to execute the instruction, and you're going to move to holes. If later on you will see the PS over here. I think I prefer it to be PS. I love to write letter last time when I'm teenager. Not only teenager, until now I love writing writing. So PS is one of the keyword that I really like to do. Okay, then over here, if there is instruction disable, if you disable the interrupt, you're going to go to the flow back. You're going to go to the started flow back. But when you enable the interrupts enables, then you're going to check the interruptions, process interrupt. If let's say there is an interrupt, then you need to do the interrupt process. This fetch cycle, execute cycle, and interrupt cycle. So program execution has only if, okay, program will execute. It's going to execute to the host only if the machine is turned off. Some sort of unrecovery error occur, and also a program instruction that holds the computer is encountered. So this is the only three things that make your execution code to go to the host process. So now we're going to look into the indirect cycle. Okay, you can see over here, if you have the fetch operands, if required, you're going to have the process of indirect. So it is in your fetch cycle. So indirect cycle, what happened? We can think that the fetchings of indirect addresses another instruction stages. So basically you have fetch and then execute again, which is you are doing a looping, right? MOV AX 10. Okay, I just repeat the similar operands and addresses. I just change the operations. Let's say sub AX 10 sub AX 100. So assuming it is all the hexadecimal value, or maybe it is addresses, it depends. As long as what will happen is you fetch this code and then you do the execution, which is you process fetch, which is you going to do decode, and then after you finish, you're going to do the operations, and you're going to do the storage of the data. And then after that, you're going to finish the cycle, which is you finish this single line. And after you finish, you're going to do looping, which is you're going to move to your next instruction. To go to your next instruction, you're going to do the similar things, which is fetch. You do the fetch, you do the decode, and then if necessary, sometimes if necessary, you're going to do the indirect. What will happen for your indirect? If your fetch operands, if required, so in fetch cycle, you're going to fetch the instruction and decode it, right? So you're going to do this, and if required, you're going to go to here. But in normal process, you're going to fetch your single instruction, and then after that you're going to do the decode. After that, you're going to do the execute. What will happen in execute is you're going to perform the operation. This is your operation. Going to perform move. If necessary, you need to store the value. So that will happen into your execute. You finish one single line, you're going to move back again to your fetch. You did the similar, which is you fetch this single instruction, and you're going to decode it. After you decode, then you pass to your execute again, and you do the operation and you store if necessary. So that is basically happen. But sometimes there will also occur the interrupt. So that you're going to do execute, there is interrupt, and you're going to go back to your fetch flow until your code is finished. And maybe sometime also you are having instruction, which is your computer turn off suddenly, going to go to your house, this one, after your executes instructions. And in meantime you are looping your instructions, your fetch also there is another some step, which is if required you need to have indirect operation. So from fetch it's going to go indirect and go to execute. So depend after that execute whether it is back to fetch or maybe it is doing an interrupt and loop again. So we can think that fetch indirect addresses another instruction stages. The main line of activities consists of alternating instruction fetch and instruction execution activities. So this is the main line of your activities, isn't it? As I mentioned, normally you're going to have your fetch and also execute. So this is your main line activities. Following the executions and instructions may be processed, maybe okay, it is not a must. Maybe there is a instructions may be processed before your next instruction. Before you going to your another instructions, maybe you need to have the interrupt, then you're going to go to your fetch and then it's continue. Okay, so wow, this is a quite big figure, which is instruction cycle stage diagram. You already look into state diagram in your digital logic last module also. In our early module, I forgot which module, we already look also in our stage diagram in terms of your programming stage. Now we look back again. So we go we're going to start with the fetch. So when we have the instruction phase, what we're going to happen is instruction operation decoding. So this is your code, instruction, address, calculation and so on. This one is under your operation instruction complete, which is your next fetch instructions. Then this is instruction phase. First thing you need to do, okay, this is operation for your fetch and instruction operation decoding. After you done your decoding instruction, what you need to do, maybe you're going to have another stages, but maybe you don't. You can see over here, you're going to go to the operand address calculation. This one is another process under fetch again. So you're going to look into your operand. So maybe I can put over here. So you're going to fetch your first single instruction first. This is your instruction. And you're going to perform the operation of decoding. You're going to decode this instruction. Operand address calculation. This is your operand. So you're going to calculate what happened is inside. Let's say this is 100 hexadecimal, or maybe it is in decimal. You're going to convert to your hexadecimal. So it's on your operand calculation. After that, your operand fetch. You can also have a multiple operand, of course. Going to have another operand, and maximum you're going to have 3, isn't it? So it depends. If you have a multiple operand, so it's going to have a loop over here. Then operand fetch again. you have maybe you can also have the indirect operation. Same goes to here. After you fetch instruction, you decode. If required, you're going to have the indirect. Same to your state diagram. After finish all the executions of your decoding and etc., if necessary, you have the indirect operations. Then you're going to move to your education. So data operation, you can see over here, your data operations, you're going to check your data operation, whether it is operand data calculation, and your operand store, you're going to store if needed. You can see same goes to here. Where is it? Okay, store the result if required. This one is on the move, and then or your operand address over here, and you're going to store the value if needed. And you can also have a multiple result later on if you have more than one operands. Then you're going to do the interrupt check. This one if you enable your interrupt. If your interrupt enabled, you're going to do checking on your interrupt. If there is no interrupt, you're going to go back to your first step. But if you have the interrupt enabled, going to do the interrupt and then you go back. But you're going to also return for the string or vector, and over here again you're going to continue looping. So basically this is similar. This is also similar in term, the different only in term of how the picture look like, and also this is the flow table instruction cycle, and this one is on the state diagram. So another way to view the process, see another way. So same is shown in figure with more correctly the nature of the instruction cycle. Wait, okay. Over here you can see instruction fetch, and then go to the instruction operand decoding, operand address calculation, operand fetch, data operation, operation address calculation, operand store, instruction check whether it is interrupt or not. Then it's going to continue. Okay. So over here we're going to look into the data flow. The exact sequence of events during an instruction cycle depend on the design of the processor. See, you have several new term. This one you're going to see later on. You will always use this term name. MAR, MBR, PCIR. So please make sure you memorize it first before we proceed. Okay, then you can see over here we have the MAR, memory address register. MBR, memory buffer register. PC, which is program counter. IR is instruction register. The exact sequence of events during an instruction cycle depend on the design of the processor. So the exact sequence, so if you look into the sequence like this, basically the exact sequence during your event, your source code reading, execute and so on, it's depend on the design of the processor. So let us assume that a processor employ with this kind of thing: MAR, MBR, PC, and IR. Maybe this is a new maybe this is a new terms for you, but maybe some of you already know about it. Each of the smaller cycle consists of a series of steps that involve the processor register micro operations. So each smaller cycle consists of a series of steps. Conventional format using register transfer language RTL. Example, IP and then IP plus 1. You can see over here. And then you have PC, PC plus 1. Later on, you're going to see that if let's say you have a register of IP equal to 100, then your next state is going to be IP equal to 101 and so on, because you have plus. But this one is don't make confused again. This one it is just example, just for you to understand. Later on you're going to use this RTL, which is register transfer language. You're going to transfer the value, because this going to be explained in detail in 5.5 and also 5.6. So don't we're not going to see deeper in our 5.3 subtopic. This is just the introduction for you. Okay, as we know, our first cycle process is under fetch cycle. An instruction is read from memory. If you have instruction which is read from your memory, and instruction is read from the memory. So data flow fetch cycle, this is what happened inside your CPU. You're going to see that you have a bus system, isn't it? You have the address bus, data bus, control bus, and it's going to connect to the memory. If you look back in your 5.2 or 5.1, you're going to see your CPU are connected to your register. Inside your CPU there is a register. It's connected to each other. Let's say this is your CPU. You have the ALU. It is connected to your register, and then you have the control unit, CU. It's connected using your bus system, data bus, address bus, and so on. There is interconnections, and these two also can be connected, which is with your memory. So that's why you can see you have a link to your memory. And inside your CPU, last time you see only these three elements: ALU, your register, and also your CU control unit. But now you can see you have the PC, you have the MAR, you have the control unit similar, you have IR and MBR. Please make sure you remember all the term, which is MAR for your memory address register, still under register, see. So all of this is a register, and PC is your program counter. Memory buffer register, instruction register, IR. Where is it? Okay. So this one is register. This one is your program counter. So please make familiar with it. It is not PC. It is not your computer. What else? Okay. This is just the overview. Later on you will see the movement, how it's going to move from your control unit to your PC, to your MAR, to your data, to your bar system, and then go back to your MR, MBR, and IR. You only see when you click F11 or F10, or you just do the debug, going to see the output at your terminal output. In a blink, in a second, you're going to get the output. But basically what happened inside your CPU, this is going to be happen. Okay, the fetch cycle can be written symbolically using RTL, as this is your timing sequence. You can have longer than this. It depend on your source code. How long your source code. So MAR, you can see over here. First of all, what will happen at the first time, which is under your first cycle, you're going to put the value of IP or PC to your MAR. And then in the MAR address, you need to look the value inside. In the value inside, let's say it is 400. At this 400, if you have a stack, if you still remember, let's say this one is 400, this is 401, 402, and etc. It's continuous. Then you need to look into inside the value of this address. So inside over here, maybe this one is 10 hexadecimal. So you're going to pick this value and put it into your MBR. And your value of your IP or your PC going to be increased +1 after you done this T2, timing 2. After that, your value of your MBR will be putting inside the IR. If it is 10 over here, similar to this. Okay, let's take a look into it in detail. So for T1, the PC contain the address. Content of IP or PC is loaded to MBR. Same, whatever I explain here, similar to the explanation here. So your PC, let's say it's contain the address, which is, let's say, 400. This is the explanation here. Content of PC is loaded. You need to see what is value inside the 400 address. Then you're going to, let's say this is a 10, right? 10 hexadecimal, let's say this value. Then you're going to load it. You're going to put inside your MAR. Sorry, this one, MAR. You're going to then transfer to your memory on your address bus. Before you move to here, you're going to do this one. Okay. Next, you will activate the read signal of the memory. So what happened is you need to load from this value, but you did not send yet to here. So you just load first. You just load to your MAR. Then you're going to transfer to memory on the address bus, but it is just transferring, not yet sent to the register. Next is you will active the read signal of the memory. Next is T2. The instruction is accessed from the memory and transfer. Now is transferred to CPU on the data bus. After you already transfer, you're going to load the value inside your MBR, into your MBR. At the same time, dalam masa yang sama, you're going to see the value of IP will increase. If the beginning is 100, now your IP is 101. Okay. Finish your T2. Now your T3. Your T3 instructions in MBR, this one, the value here is loaded. You're going to put it into IR. Last time it is 10, right? So similar, you're going to put 10 inside your IR. The opcode of the instruction will be decoded and translated so as to determine the micro operations for the particular instruction. The opcode of the instruction will be decoded and translated so as to determine the micro operations for the particular instructions. So you're going to finish the fetch. Now this one is in terms of wording. It is in terms of wording. Wait. Next example, you're going to look into the diagram. This diagram. Okay. Once the fetch cycle is over, the control unit examine the contents of your IR. So you can see over here, you already have the IR value, right? You finish the fetch cycle. But then if you have the indirect cycle, go back to your diagram. Wait, okay, this one.
It's 2 hours.
If you finish the fetch, sometime you need to have the indirect, isn't it? So this is going to be shown in this example here. Okay. To determine if it contains of operand specifier using indirect addressing. If, let's say, your operand is having indirect addressing. So it's going to see where is the picture. Okay, you can see over here, this one after you finish. Then if you have the indirect cycle, what will happen is you're going to check back your MBR and then go to your MAR, go back to your address and etc. Later on you will see the flow. So please be patient. Okay, this is the flow. Fetch cycle indirect addressing can be written symbolically using RTL. So you can see over here, where is it? At the beginning, this one, RTL. Now you find where you need to apply it. It can be also written symbolically using RTL for the fetch cycle indirect addressing. The operations is T1, T2, T3 are the timing sequence as similar to previously on your fetch cycle. You have the IR operands or address. So depend if let's say your IR value is let's say 10 hexadecimal, then it is under operand only. Or if let's say it is address, you're going to look into the address. Then you're going to put into your MAR and doing this all, but we're going to see it in detail in this page. Okay, in our T1, the IR content of indirect address that loaded to MAR, which is indirect address, then transfer to memory on the address bus. You're going to transfer the value if once you already give to your MAR the value, then you're going to transfer it to your memory. You're going to send to this, but not yet. You just use the address bus. Next, the CU will active the read signal of the memory. If you look here, it's similar to all of these, only in terms of slightly different, but the flow is basically similar. Next is our T2. So our T2, okay. Our T2, you can see data, your operand, if it is 10, then it's the operand data, is accessed from the memory and transferred to CPU on data bus. You're going to transfer it and you will load it into your MBR using your data bus. So you will see what all these bus are used. You can see you have the address bus, you have the data bus. So first you have the MAR, you're going to use the address bus. Your address bus will connect, then after that you're going to use your data bus to store the MBR. See, all the picture already shows the connections. For the third step, it is T3. Data MBR is loaded into IR. So you're going to load into your IR back. The opcode of the instruction will be decode. This one is similar to previous fetch cycle. And determine the micro operation for the particular instruction, similar on also. So you can see MBR over here. Basically it's going to be to your IR operand. You're going to put it back. Okay, now we look into the example. Involved with fetching data from memory before initiating the execution cycle. You were given the single instruction. So what is your single instruction? The single instruction is add AX And this one is the addresses of 2400. First of all, what is happening? Your control unit will request the memory read. That will come out your initial value. If it started with 0, then it's going to be 0 and so on. So first, your control unit will use your control bus to request your memory read. So this is the first thing that happened. Second, when you have the memory revert back, the result is placed into the data bus. So you can see it's going to be placed into your data bus. And from your data bus, you can see the connections. It's going to copy, which is going to be stored and loaded into your MBR. At AX2400, this value is inside your memory. The address is moved into your MR. So this address will be moved into your MAR. Then place on the address bus. You can see it's going to place back to your address bus over here. So this is example for indirect cycle if you have this single instruction. Only for the indirect cycle, not all the flow for your fetch cycle. That's why it's only small part. And second, you have the execute cycle. The opcode of the instruction in IR will be decoded and related control signal will be generated. This one, the flow we already look into, but we're going to go deeper. Type of opcode, there are several. This one also we already learned. Processor memory, processor input output, data processing, and then control. What is the definitions is for the processor memory, data transfer between CPU and main memory. For input output processor, data transfer between CPU and input output module. Data processing, some arithmetic or logical operations on data. And lastly, the control, alterations of sequence of operation. This table also we already discussed. I forgot which chapter, but this is the recap, I guess. So here you're going to see what is happen in your execute cycle. This is the example. Content of memory and register in hexadecimal. You were given the address. Instruction, you need to add. Let's say you have AAX. I just give you an example. 194 and then 941. Okay, maybe the instruction look like this. Okay, this one is 941. But maybe you can add another one. Move 941 inside your register over here, EAX. Okay, tak nak pening-pening. Now our first step. first step, your control unit will see the memory. What is in your memory? So in the memory, it's going to be stored in your IR. But this is the address, particular address for these two under your source code. You can see the value inside. One is 3, one is 2 in decimal, hexadecimal. Similar hexa and this decimal, hexadecimal is similar if it's 3 and 2. And second step, you're going to put this value inside this one. Going to put into your SC here. Now you update your SC is going to be 0003. And your command, your instruction, add. So you're going to add. Okay, there is a step-by-step over here. I prefer this one. PC is 300, address of the first instructions, which is your initial value. The value of 1940 in hex is loaded into your IR. PC is increment, so it's going to +1 later on. So now your PC is 301. In second step, you can see that the first bits 1H in the IR indicate that AC is to be loaded. This one. The remaining 12 bit specify the address of 940. See? This address. From which data is to be loaded? Dari mana data yang akan di-load? Okay. You're going to see you have 1940 in your memory for the first address. And 1 over here means that it's going to be loaded in the IR. And this is the address from where it's going to be loaded. So it's going to be loaded from 3. This a reminder. Okay, go to 940 and get the data. Which one? This one. And load into your AC. So this is second step. For your third step, the next instruction is 5941. Is fetched from location 301. What happened is because the PC is already increment. So this one, this new value will be stored in your IR. And your PC will increase again. Fourth step, the old content of AC. This is the old content of your SC. And the content of your 941002 are added. Because you're going to add these two value inside these two addresses. And the result 0005 is stored in the AC. So you add over here, going to store inside your AC. Step 5. The next instruction 2941 is fetched from location 302 because your PC is already increased. Now you're going to increase again. 303. It's going to be continue basically, right? Then you're going to store this value inside your IR. The content of SC, you can see, are stored in the location of 241, location of 941 over here. The content of SC are stored in the location of 941. So you're going to take this value and put it here. Same goes to this one. Now we look the summary of all under your execute cycle. The piece, I guess it's similar, so you can try to look into one by one what is happening basically in your 1, 2, 3, 4, 5 step. I already go through one by one and two example. Now you have another example, but is under fetch cycle. Previously it is under your execution cycle or program. Now we're going to move to our fetch cycle example. So here we have the example of codes that were given. This is instructions. Single instruction, move AX, and then there is a num. This is the table of your memory. So first of all, ada tunjuk tak mula-mula? Okay. First of all, your control unit will go to find the value, the initial value using your control bus. And you can see over here, it's going to find the first value. It's going to be find the first value, the starting with 100. But over here, it's mentioned as a num. You can see the first value is 100 for the address. Then it's going to be go to the PC, and your PC value is 100. And your PC will store the value inside your MAR equal to 100 again, but later on you will see it's going to go to the address bus to check what is the value inside this address 100. So you can see it's going to go to address bus, and from here it's going to check what is the value inside this 100. Dia pergi ke sini. It's going to go here and it's going to find. Now you will see your 100 is move AX 450. Okay, I delete. Okay, now you can see you look into this one. And next step, this value, you can see this value, you're going to later on it will send back from your memory, it will send back to your data bus, and then it will give to your memory later on what is the value inside. If it is 450000A, it's going to be that value. And you're going to store inside your IR. That is under your fetch cycle. It's going to continue looping and looping. This example is indirect cycle. still same, but it is under indirect cycle. What happened is, first of course you're going to have your control unit as the main leader, as the team leader. Control unit will first check and connect using your control bus to your what is this memory, your memory, and it will look into the first what address, and you will have this, and your memory then go back to your data bus and go to your MBR. Okay, I delete. Go to your MBR. Last time your IR, you can see previously your IR value is this, and you can see your MIR later on will be sent to your MAR, and you need to look into your MAR. Your MAR will use your address bus, and from here you will look into your memory again, and what is the value for 450. Then it's going to continue with the control unit and flow non-stop until you end of your source code, or maybe there is instructions. Okay, when you see over here, it's pointing from your MAR, it's going to be continue, and you can see your 45A is the value of 000A, so it's going to store this value into your AX. And we have another example, so that you can understand it more clearly. You can see this is the same command source code for you, and same also table for your memory. First, what you need to do is you need to find for your control unit will instruct the value of your initial memory. Okay, now you're going to see you have 100, so your IP or PC will be updated with 100. So this is the first. Later on you will see that your PC or IP will increase, but it's not now. Now you're going to move your fetch cycle, under your fetch cycle, going to move this value to your MAR. And for the T2, next step is you're going to see your MAR over here, and in the address, see, you're going to see in the address, and later on you will increase 101. Okay, oh, this one MBR, your address over here, MBR, you're going to look into the address. Inside the address is this value, so this value you can see you're going to store into your MBR. You have 450. Now you can see over here you have where is another 4? Wait, 440. Oh, it is continuous. A 0, but it's okay. Okay, can see over here. Next step is your MBR. Your MBR is 450. This you're going to see address over here, which is indirect cycle. So you have the value of 44450, and you're going to do the II operands or addressings depend on what is the value inside this. Before that, you're going to move this value to your MAR. Operand. This is the operand or the address for the IR. Now for the T5 MBR, you're going to move this to here, education cycle. So you have 405, this value. You're going to put your MBR 000A. And lastly, your MBR, this your MBR will be putting your at your AAX. This. So it's quite easy, not too hard. So this is the example of the answer. You can screenshot and try to do it by yourself without guiding. And you have another example, trace educations of the instruction. You can see over here, it's give you like block, but you were given with the initial memory. Okay, this is the instructions. So first of all, the control unit will check with your memory, and it started with 0110 100 started over here, and then after that you're going to put this value similar to your MAR, and your MAR will later on check your memory for the 100. What is the value? So you have the value of move AX and okay, I tunjuk macam ni so it's more clear. So now you can see you're going to have this one because you are pointing to your memory. You want to check the value. Now after that, you're going to move the value inside of this address 011. You're going to see, you're going to store this value. So over here, let's say you have 103. You can see N. At 103, this is the value of N. You will put it into your IR. So if it's indirect addressing, it's much more simpler. Please try to do it. You need to check our last stage. Our last stage is 0103. So you have the value of N is 9A. You're going to store it, and so this exercise we will also discuss together, but I guess I'm not going to touch it yet because I'm going to focus it one by one, so that we're going to have much more clear understanding. Next, under interrupt cycle. Okay, let me touch in this video. So in next subtopic, subtopic, we're going to cover our next subtopic later on in our next video. So here I'm going to share with all of you two exercise. based on our previous example, so I already copy paste over here. This is the memory for our first initial for the example given. So now I'm just copy paste it to the exercise so then you can see it clearly. First of all, what you need to do is you're going to pick check your control unit. You're going to go to your control bus to go to your register initial value, going to start with 0110. So that's why you will put this value in. Second is you're going to do the fresh cycle. This one will be putting inside your MAR. And after that, your MAR, you're going to see your MAR will be putting this value inside your MBR. But before that, you're going to see that you also what happened? You also will increase the value of IP. And what is the value of your MBR is all inside this one. See? This is the address of 100, and what is inside this, there is a operand, then you're going to store it here. Next is IR. Your MBR will push will be put into your IR. So IR will be similar also. I don't want to write it too long. I already start lazy. So this is indirect cycle performs. Next, you're going to see that you have MAR. Your IR operand's address. So over here, you need to see your address of your N. Let's say your N is at this address. So you're going to find the address of 103. See? So you will put the address of 0103. After that, your MBR, which will be put your memory of your MAR address. Your MAR 103. Your memory inside is N equal to 98. This one, right? Where is my A? My A is ugly, so you can see over here. And lastly, your value, you're going to put your value of your MAR into your AX register. So lastly, you will get A. Okay. So if you have the instructions of AX 90A, so you will be directly, if you use your Visual Studio, you're going to, and it's in your Chonga, in your direct solution, you will see that you're going to store the value of AX with 9A, isn't it? But inside this is what happening in your computer. Now you have a second example, exercise 5.2. So trace the executions of instruction by showing all the changes in CPU register, control and general purpose register, as well as the micro operation related to the instruction. Use the given initial table. So this is the initial table. You refer back to this table can also, but in term of it's quite easy. Alamak, dah terus keluar jawapan. So what you're going to do is first of all, you're going to see the initial address is 39D. Let me show it step by step. Allahu Akbar. It's okay. I just share, okay. Over here you can see that first of all you're going to see the initial value, which is 39D, and you will put into your IPOPC, and your IPOPC will be putting into your MAR. Your value is similar. After that, you're going to add your IP with +1. So in hexadecimal, if you +1 D after D, it's going to be E. So it is 39E. And your MAR value, this one, you're going to see inside of this. This is inside of the memory. 450. This A is not the value, but the value of your address is 450 only. Then you're going to jump to your 450. But firstly, your MBR will be updated with the value of this one. So that's why your MBR is A450. Next is your MBR will be putting into your IR. So your IR similar value. Only then your IR address. So the address is only this one. So the address is 450. So you can see over here 450. You're going to put the address. The IR address is 450 to your MAR here. Then you're going to see inside the value to be put into your MBR. This is 100. And you're going to execute the exchange CX num. So your num is your value of your 100. So you're going to exchange. Firstly, your num value is 100 and your CX is 200. And you're going to put exchange is together. CX will be 100 and your num now will be 200. Next is you're going to put your MBR to the MAR address. Your MBR will be putting into your MAR address. So your MAR address will be a num. Then you're going to continue. Basically what will happen now is the next instruction. So you already finished with this. Your next instruction will be 39E and continues until you finish all, execute to the jump L1. So please try to do it. I show you the answer and you can screenshot. I'm going to stop this video until here only. Later on I will meet you again in our next video in our new subtopic, which is interrupt cycle. Okay, so thank you for your watching, and please make sure be safe and bye.